Yeah, welcome to viewers again. Here we will discuss about irrational numbers. Now when we say irrational, that means something which is not rational. That means a number which is not rational will be called as irrational number. Now what is a rational number? This we have discussed earlier. A number which can be expressed in the form p by q, where p and q are integers and p and q are co-prime q not equal to 0. This is the definition of a rational number. That means a rational number can be expressed as a fraction where p and q are integers, p and q are co-prime. That means p and q, they do not have common factors other than 1. They are only divisible by 1 only. Common factor is 1 only. And q is a non-zero integer. Means denominator should be non-zero integer. Say for example 3 by 5 minus 4 by 5. 0. 0 is also a rational number, since 0 can be expressed as 0 by 1, 0 by 2. 1 is also a rational number. 1 is 1 by 1, right? P by Q form. And similarly 2 is a rational number. 2 can be expressed as 2 by 1. That means any integer can be expressed in P by Q form. So all integers are rational numbers. Conversely, we can say all rational numbers may not be an integer. Say for example 5 is a rational number, it's an integer, but 5 by 7, it's a rational number, but it's not an integer, right? So all integers are rational numbers, but all rational numbers may not be an integers. Now what is irrational number? A number which cannot be expressed in p by q form, where p and q are integers, p and q are co-prime numbers, q not equal to 0. That means a irrational number you cannot express in this form. Now think about the fraction 2 by 5. Suppose you divide 2 by 5, so it is not exactly divisible by 5, so we put decimal here. We got 20, so 5 4s are 20, right? So its decimal expansion is 0.4. Similarly, say for example you divide, say 95 divided by 8. Suppose 95 divided by 8. 8 1s are 8. 9 minus 8 1, 15. 8 1s are 8. Remainder 7. Now we put decimal here. 8 7s are 56. 8 8s are 64. 8 9s are 72. So 8 8s are 64. But this remainder is 6. So we get 60. 8 7s are 56. Remainder is 4. 8 5s are 40. Right? So decimal expansion of 95 by 80 is 11.875. Now think about another decimal expansion. 1 divided by 3. Suppose 1 divided by 3. 3 3s are 9. 10 minus 9 1. 3 3s are 9. Again you find 3 3s are 9. So every time you get remainder 1. So this is 0.333. Means you find 3 is repeating after decimal. Think about another number. Say for example 1 by 7. You divide 1 divided by 7. 1 divided by 7. 7 1 is 7, 7 4 is 28, 7 2 is 14, 7 is 56, 7 5 is 35, 7 7 is 49. Again you find 7 1 is 7. So this will continue again, right? So you find that 0.1 by 7 means 0.142857 42857 again 42857 . That means this group of numbers is repeating at a certain interval. 1 4 2 8 5 7, 1 4 2 8 5 7. Then again it is starting from 1. 10 minus 7 1. Next again you will get 2 8 4 8 2 5 7. This group is repeating. So you find that there are some numbers whose decimal expansions are like this. First one is, see, after one step of division it comes to an end. 95 by 8, after 3 steps, 3 decimal steps, it comes to an end, right? So we call this type of decimal as terminating decimal. Means after finite steps of division, the remainder comes to an end. It is called terminating. Terminating means something which comes to an end. So after 3 steps of decimal, the remainder becomes 0. Similarly here, after only 1 step, remainder becomes 0, right? Here you see every time remainder is same. So the quotient you find 0.333, every time it is 3 is repeating. This is called a recurring decimal or a repeating decimal, and this is terminating but not repeating decimal. Similarly 1 by 7, you see 1 by 7, in case of 1 by 7 you see it is terminating but repeating. Means remainder becomes same at a certain interval. It is terminating but repeating. Now this type of decimal we call rational numbers. So rational numbers have terminating decimal, or non-terminating but repeating, or we say recurring, right? So rational numbers have terminating decimal or non-terminating, recurring or repeating decimal. Let's take one more example. Say 2 by 7, suppose. Divide 2 by 7. 7 to the 14, 6 0, 7 is 56, 0 7 5 is 35, 7 7 is 49, 7 1 is 7, 7 4 is 28, 2 0. Again this you find this same one. So this will start again. 7 2 is 14, 7 8 is 56, 4 0, 7 5 is 35, 7 7 49, 7 1 7, 7 4 28, 2 0. So you see the decimal expansion of 2 by 7 is 0.28571 again it is repeating 285714. This will repeat at a certain interval. At equal interval you will get this group of digits, right? So we call the rational numbers have terminating decimal or non-terminating but repeating decimal. In this case it is non-terminating but repeating decimal, recurring decimal. Now think about a group of numbers, say for example decimal expansion of square root of 2. You see, decimal expansion of square root of the 2 is like this. It is not repeating. So similarly decimal expansion of square root of 3, you see, this is not repeating or recurring, and it is not even terminating. Similarly this number 1.01, dot dot dot. So in every step you see number of zeros are increasing, so this will not come to an end. Similarly 2.31, 331, 3331. So you see in every step numbers of 3's are increasing, so this will not come to an end. Similarly this one 5.21, 211, 211, 2 4 times of 1, 2, then 5 times of 1, so this will not come to an end. And now this type of decimal expansions are called irrational numbers. So irrational numbers have, we say irrational numbers have non-terminating and non-repeating decimal expansion. So we got to know two very important things, that rational numbers have decimal expansions like terminating or non-terminating but repeating recurring decimal expansion, whereas irrational numbers have non-terminating and non-repeating decimal expansion. This is this non-terminating and non-repeating. Here 1 is repeating, but every time the number of ones are increasing. First 1 numbers of 1, 2 numbers of 1, next 3 numbers of 1, 4 numbers of 1, 5 numbers of 1, and this will go on increasing, so it is not repeating. Similarly here also numbers of 3's are increasing every step, it's not repeating. Here also numbers of zeros are increasing, it is not repeating. We say repeating only if every step we find 3 numbers of 0 in every step, but here numbers of zeros are increasing in every step. So this type of expansion, decimal expansions, are called non-terminating, non-repeating decimal, and irrational numbers are said to have non-terminating and non-repeating decimal expansion. Now let us discuss why square root of 2 is irrational or square root of 2 is not a rational number. That means square root of 2 cannot be expressed in p by q style, where p and q are integers and p and q are co-prime numbers, q not equal to 0. So let's say square root of 2 is a rational number. So square root of 2 is rational. Suppose p and q are integers, p and q are co-prime, and q not equal to 0. So here you are assuming that square root of 2 equal to p by q, where p and q are integers, p and q are co-prime numbers, means they don't have common factors other than 1, q not equal to 0. Q is a non-zero integer. Now square root of 2 equal to p by q. That means square root of 2 square equal to p square by q square. We are squaring both sides. That means this implies square root of 2 whole square means 2 equal to p square by q square. Square root of 2 square means square root of 2 multiplied by square root of 2 square root of 4, that is answer is 2. Square root of 2 whole square is 2 equal to p square by q square. This means twice of q square equal to p square, or we can say p square equal to twice of q square. Now you see p square is a multiple of 2 times of q square. That means p square is even number. When an even number is a multiple of 2, any even number, 8 equal to 2 multiplied by 4, 12 equal to 2 multiplied by 6, 2 equal to 2 multiplied by 1. So when we say, when we multiply a number by 2, that means we got an even number. So 2 multiplied by q square means this number is even, since 2 is a factor of this product. So p square is even. P square is even. Now you see, if p square is even, p is also even. We know square of an even number is even number. Say for example, square of an even number, 2 square equal to 4. 2 is even, square of 2 is even. 4 square equal to 16. Square of even number is 16. 8 square equal to 64. Any even number. 10 square equal to 100, etc. Right? So square of even number is even. That means square root of even number is also even number. So if p square is even, p is also even. Square root of p square is even. If p is even, let p equal to twice of m, where m is integer. Suppose. So we are assuming that if p is even, p equal to twice of m, where m is an integer. Right? If p equal to twice m, now you see twice of q square equal to p square. Q square equal to p square divided by 2. From this relation we got q square equal to p square divided by 2. Now what is p? P means twice of m whole square divided by 2. This means 4m square divided by 2. This means 2m square, or 2 multiplied by m square. Now you see q square equal to 2 multiplied by m square. That means q is also even. Q square is a multiple of 2 and another number. So q square is even. That is, if q square is even, q is even. Right? Q is even number. Q is even number. That we already discussed earlier. If square of a number is even, then its square root is also even. So if q square is even number, square root of q square is q, q is also even number. Let q equal to twice of n, where n is an integer. Right? Since q is an even number, so we consider q equal to twice n, where n is an integer. Now you see square root of 2 equal to p square. P is even, q is also even, right? So we got p square, p divided by q, p equal to twice m, q equal to twice n. That means p and q have common factor 2, right? That is, p and q have common factor 2. But Earlier we considered p and q are integers, p and q are co-prime. That means they don't have common factor. But here we got p and q have common factor. That is 2 is a common factor of p and q. So we got a contradiction. We assume that p square root of 2 is a rational number where p and q are integers, p and q are co-prime. That means they don't have common factors other than 1. But while assuming this, we got that square root of 2 is a rational number where p and q have common factors other than 1. They have common factors, and that is 2. Therefore our assumption was wrong. We assume that square root of p by q, p and q are integers, p and q are co-prime, q not equal to 0. That means we considered square root of 2 as a rational number. But while assuming this, we got a contradiction. We find that p and q have common factor 2. That is, our assumption was wrong. That means square root of 2 is irrational. That means we cannot express square root of 2 as a rational number in the form p by q. That means square root of 2 is irrational. We will discuss similar properties next time. So thank you for watching. Bye bye.